Good afternoon. Welcome to the plenary session of the CTO Summit. The CTO Summit threads through the next 3 days of the ITS World Congress. There's 2 sessions today and 1 each on Tuesday and Wednesday. Brings top technical leadership together from across the industry to debate and discuss intelligent transportation systems of the future. And I can think of no better way to kick off the CTO Summit than to hear from Rodney O'Neill, CEO and President of Delphi Automotive, and my boss. So I can speak firsthand for his passion and steadfast support for technology. As he successfully guided Delphi through a difficult industry downturn and our successful transformation, he never took his foot off the technology pedal. He never wavered on technology investment, and that's still true today. But it has to be technology that solves problems, technology that makes a difference in the market, and technology that brings real value to customers. I'm proud to introduce Rodney O'Neill.
Thanks, Jeff. Good afternoon, everyone, and thank you for joining us today. Industry experts predict fully automated vehicles on the road by 2025. Now, if that's the case, it's time to get real about the challenges that lie ahead. So no one questions that automated driving has a very interesting future. What is questionable, though, is the form that this will take as we go forward. Now, here's a short video that presents Delphi's look ahead on the path to automated driving.
Hello, everyone. Welcome to my family's version of the much-loved classic, School Drop-Off. Please meet my sister, your typical overachiever with a heart of gold. This is my brother, fully equipped with standard older brother features. And Dad, one of the best on the road. And me, your trusted narrator. On with the show. Thanks to the engineering team at Delphi, passionate about making a difference and dedicated to intelligent innovations that matter, I don't have to be a backseat driver. But I do spy a car backing out of its driveway a little too quickly for my taste. Thankfully, our radar and vision fusion system has detected the closing distance and speed between cars. And Delphi's 360-degree sensing provides a full scan of the road ahead and around our car. The data, along with the GPS and navigation technology, alerts Dad to the fact that he's going to need to stop and avoid an uncomfortable conversation with our neighbor. Can you get enough of how effective this technology is? Though Dad always keeps his eyes on the road, why not have the car co-pilot a while? Because distractions can fly in from anywhere. With the automated driving system engaged, Dad is able to settle him down. Good thing, because I see traffic slowing down. Delphi's radar and vision fusion system has picked up the closing distance and speed between the cars. A 360-degree scan of the road, with the GPS and navigation technology, provides road conditions, determining that it is safe for us to change lanes, avoiding the slowed traffic. This time, our car completes the maneuver on its own. One day he'll realize that this is far more interesting than that. There are times when Dad distracts himself, like every time he tries to figure out who this week's love of our life is. Yoo-hoo, driver. Seems we are veering a tad. However, in the trusted hands of Delphi's award-winning radar and vision technologies, our car sticks the drop-off landing. I so look forward to the dropping-off part of drop-off. I get to marvel at Delphi's unique, extensive portfolio of automated driving capabilities. Complex, yes, but delivering simple and important driving improvements. And I get to experience today how driving will be for me when these flywheels are mine. And above all, drop-off means I finally get to be more than a backseat driver.
Now, there are many issues we need to focus on before we can realize the vision you just saw and can move forward to a fully automated vehicle. Now, I don't pretend to have all the answers, but I sure do have a lot of very real questions, compelling considerations that we need to address if we're going to make fully automated vehicles a successful reality. Let's start with this. How many of you still have those 3D TV glasses? Remember how that was supposed to have taken over the world? And that's right, you know, the world always has a way of sorting things out. And then there's this. Just because we can do something technically, should we do it? And do we really want to remove the driver from the automobile? Now, certainly, customers want their vehicles to be safe, and we wholly believe that safety improvements is something that we all ought to do in this industry. So we should not dismiss any technology that makes the vehicle safer. Yet, even here, there are questions such as, how do we balance the need for safety with the demand for connectivity? Buyers want safety for themselves and their passengers. They want a seamless user experience at home, at work, on the move in the vehicle. But more connectivity can increase the opportunity for distractions. So what's the balance? Buyers are willing to pay for connectivity, along with active safety technologies such as advanced driver-assisted systems to help prevent accidents before they can happen. This convergence of safety and connectivity sets the stage for automated driving. Still, though, more questions remain. Like, when are we going to make full automation affordable? There are many, many working examples of fully autonomous vehicles, but they're not affordable, and they certainly are not proven in the real-world environment. Now, sure, there are just huge advantages to automated driving, like reduction of accidents and fatalities. But we do have to ask ourselves, are drivers willing to pay for technologies that deliver these types of advantages? Do we even need full automation? Where's the payoff for all concerned, the return on investment? Yes, vehicle owners will see a value, but ultimately, the vehicle must be affordable, and it must work with the surrounding infrastructure. So what's required? Well, all parties have to be on the same page for vehicles to talk to each other and to talk to the surrounding infrastructure. So it's OEMs working with suppliers and technology partners to provide reliable vehicle-to-vehicle communications with the main goal of reducing collisions. And it's all of us working together with the developers of the infrastructure systems, such as high-tech traffic lights and traffic management centers to ensure common protocols for vehicle-to-infrastructure connections. Without both, it's a flawed system. Now, here in Southeast Michigan, we are at the heart of the growing intelligent transportation industry, with world-class Southeast Michigan Traffic Operations Center just nearby. In addition, we are home to the University of Michigan Transportation Research Institute in Ann Arbor, which is the largest connected vehicle test bed in the world. The Michigan Institute has been working with the Department of Transportation, 8 OEs, and leading-edge partners, including my own Delphi, on a pilot program focused on vehicle-to-vehicle and vehicle-to-infrastructure communications. So far, nearly 3,000 vehicles have been on the road for a year of testing. The program was recently extended for an additional 3 years, and the test will go to include about 10,000 vehicles, as well as adding vehicle-to-pedestrian technologies into the equation. In addition, the Michigan Institute is embarking on a controlled environment test track for automated vehicles. It truly is really impressive when you think of the research and developing development that's happening right here in our own backyard in the state. And just across the U.S. border in Canada, the city of Windsor's Traffic Operations Center is using new ITS technologies that will further help to facilitate smooth traffic flows between the U.S. and Canada. So I'd say we've come to the right place to talk about the future of automated driving. So as the discussions continue today, it's important to remember that commonization among entities like these is the only path to viable automating driving ecosystem. Vehicles need to operate the same no matter where they are, even across borders. So it's clear the added connectivity and the potential of automated features change the way that we all will approach design. This will be a journey, and the destination will not be reached anytime soon. Furthermore, the questions raised extend beyond design and infrastructure. For example, there's the additional consideration of how much vehicle volume and infrastructure is enough to reach the tipping point that make the whole idea of automated driving worthwhile. And will there ever be enough automated vehicles in the car park to make the value prop very positive? Then there's the whole issue of cybersecurity. How are we going to manage cybersecurity concerns and privacy issues? These are key implications for fully integrated connected vehicles. In 2025, 60% of the vehicles will have embedded connectivity on them. And probably 100% of all consumers in the vehicle will be connected via their smartphones. Consumers need and they want reliable, safe, and secure connections. But this increased connectivity leads to more vulnerability. So what if someone hacks into the car's computer and they use the stolen information to commit a crime? Or what if the virus attacks the vehicle system and it fails? And who has the right to the information collected about driving habits? Clearly, a legal framework and government action are required. So what's been the response to date, and where do we stand currently? In Europe, already, legislation requires heavy-duty vehicles to start implementing collision-preventing technologies. For passenger vehicles, Europe has made changes to their new car assessment program, making a 5-star rating dependent on having active safety systems. Insurance companies in many countries are also enabling this effort by offering discounts to consumers who have vehicles with active safety technologies on board. But insurance companies are still seeking data to determine how to deal with autonomous vehicles. And at the same time, countries across the globe are developing cooperative ITS systems to create consistency needed to even start answering these insurance questions. Trilateral cooperation among Europe, Japan, and the United States is helping to commonize standards. In China, increasing interest in connected vehicle technology is also gaining momentum. Here in the United States, NHTSA has started working on guidelines to best manage the new industry. They issued a 5-level classification to define vehicle automation. This is recognition by the federal government that automated vehicles are a reality for the future of transportation. And at the state level, Michigan, Florida, Nevada, and California have legislation allowing for testing of fully automated vehicles on public roads. The Transportation Department here also just announced a plan to require that vehicle-to-vehicle communication be installed in all cars and trucks in the United States in the coming years. Transportation Secretary Anthony Fox called it the next great advancement in saving lives. Beyond the current response, there are key legal and liability issues to sort through. Like what? Well, for example, in every state, in most countries, laws about operating motor vehicles and insuring them all make one huge assumption. A human is behind the wheel and in control of a moving vehicle. In fully autonomous cars, Who's going to be at fault in an accident? The person riding in the car, the vehicle maker, the component maker, or the vehicle software developer? Who should get the ticket when the police pull over the car? Actually, when you think about it, how are they going to pull over a driverless car? And what about distracted driving? Does the driver have to be alert and prepared at all times to retake control of the vehicle? And if that answer is yes, then what's the real value of having an autonomous vehicle? And that brings me to the real bottom line. Who is going to pay for it? Who will pay for the infrastructure? Private industry, government, taxpayers. What's the cost-value equation for consumers? How much more are they willing to pay for a fully automated vehicle over a driver-assisted vehicle? What's the benefit? So you see, a great many real-world questions need to be addressed, which is why we're here today. Together, we can start to work out some of the answers. I encourage your feedback and input to the Delphi representatives taking part in many of the activities here at the ITS World Congress. First, will be available at the CTO Summit session here. And at the Delphi booth in the exhibit hall, you can experience driver-assisted systems in vehicle navigation systems and safety devices. And at Belle Isle, the technology showcase features many demonstrations and live activities. And in fact, you can start experiencing some of these key technologies on the ride over. 2 of the 8 buses going to Belle Isle, look for the University of Michigan logo, will have demonstrations of vehicle-to-vehicle and vehicle-to-infrastructure systems. And I want to offer a special thanks to our bus demonstration partners for the support and involvement in the project. In fact, the entire industry has put together an incredible showcase to experience the potential of these new technologies. Speaking of potential, that is the thought I'd like to leave with you today. The potential is there. However, we must answer a lot of real questions in order for any of us to fully achieve it. Is it really worth the time and effort? Just because we can do it, should we? Is the best use of our resources this? Is it going to make the world truly a better place? Because it's time to get real. And these are real questions we need to answer and answer together. I thank you for your attention. Now I'll turn it back over to Jeff. Have a good day.
Okay, thanks, Rod. It's great challenges and great questions, and it's a great way to kick off the CTO Summit. Now, no doubt, we have massive changes ahead in our industry as we evolve intelligent transportation systems around the world. When you think about our transportation systems and how things will change by 2025, we know we'll have a lot more cars on the road, we'll have stricter fuel economy regulations, and we'll have more automated features in cars as a response to the ever-connected consumer. As an industry, we are developing technologies to allow for fewer accidents, less emissions, better fuel economy, and cars with 10% or 1,000%, maybe 10,000% more computational power than we have today. Individual technology areas of the vehicle continue to evolve and in many cases accelerate. And now they're starting to converge in how they're developed and converge in how they're presented to the consumer. For example, the only way we may be able to handle the insatiable appetite of the consumer to bring their digital lifestyle into the vehicle is to marry active safety technology to connectivity technology. And no doubt the underlying high-speed computing platforms and high-speed architectures are converging. All of this providing a foundation for intelligent transportation systems of the future. But nobody can cover all these technology bets. There are just too many. So we have to make choices. We have to get real, as Rod said, in what truly brings value to the consumer. So let's get the debate started. As I said, the CTO Summit threads through the next 3 days of this World Congress. This plenary session includes 7 top technical leaders of OEs, Tier 1s, and the tech sector. So I know what you're thinking, right? 7 panelists, how long will this last? But each speaker has 6 to 8 minutes, and that'll give us plenty of time at the end for Q&A. So get your questions ready. Write your questions on the cards on your seat. Hold them up, and they'll be collected at the end of the aisles. And again, this should be provocative and informative. If they leave out provocative, make sure you fill that gap with your questions. So let's get started. Our first speaker is Ralph Leninger from Continental. He's a Senior Vice President, System Development, Innovation and Strategy for the Interior Division of Continental in Regensburg, Germany, a position he's held since 2007. Ralph?
So, thank you very much. Doing business, the best way is to solve problems. And as bigger the problem is you solve, as better the sustainable business is what you can do. This is why we are all together here on ITS, because all of us, we are treating one of the world's largest problems, which is the traffic collapse, and to find solutions in order to overcome it. And as Rodney was saying, to make the world maybe a little better place by contributing technologies to that. Technological-wise, the question is how to do on that. And one of the key technologies in order to solve the world's biggest problems is the Internet of Everything, where each and every device are interconnected together, which is today more than 15 billion devices today, and will come up to more than 50 billion devices, connected devices in 2020. What is the real methodology behind that? And this is to change from control system to closed loop system, because if each and every device is connected, each and every device can optimize themselves to each other, meaning waste down, efficiency up. Is this new? No, that's not new. There are even companies doing business in other fields, like SIM technology company. They are connecting plants. Why to connect plants? This is just to save water, because if the plant can tell to the control system, I need water, you can reach a water saving between 30 and 50%, which is huge if you're looking for the water problems which you have, for example, in Africa. So how to do it in the car? Is Continental prepared to do so? The answer is no. Why? Because in all the back-end internet technology, we do not have know-how in. So the question for us was, make it sense to reinvent the internet or to teaming up and to partner? Of course, our answer was partnership is the right way. And we have been more than pleased to team up with Cisco, IBM, Nokia here in order to have a strong technological team to make the connected car happen. Business case behind that, yes, because an assessment shows for the Internet of Everything, the total value at stake in the upcoming 9 years is 14.4 trillion, where a big portion is in the arena of ITS. So message is huge business opportunity is within this field. So where we are today, what we are doing Continental, walk the talk. Meanwhile, we have more than 26 million cars somewhere on the world connected with our connectivity technology. 21,000 companies use Continental online fleet management system. We have more than 20 other ITS projects in development. We have started a research laboratory with the government in Singapore, and having partnership, inviting the internet world into our teaming up. We have also started an office in Silicon Valley. And walk the talk, we have been sure that in Continental, 20 years automotive experience manager would not be the right person to run this office. And so we have been more than pleased to get a new colleague with us coming from the internet industry, coming from Google, who is running this show for us. Thank you very much.
Thank you. Thank you, Rolf. Our next speaker is Dr. Ahmed Bahai of Texas Instruments. He's the Chief Technologist of Texas Instruments and Director of Kilby Labs and Corporate Research. Dr. Bahai also is a consulting professor at Stanford University and an IEEE Fellow. Ahmad?
Thanks, Jeff. Good afternoon. I'm coming from semiconductor industry, and we have a passion to make things more intelligent and smart. Who could have thought of having a power of mainframe in your smartphone in your pocket today, just a few years ago? Or having all the advanced systems from radar to laser radars to camera and ultrasonic systems, which could only be available in an advanced military system in a kind of regular car today. So we have a lot of interest and passion to make the transportation and vehicles more smart. Let me tell you about the trends in industry as far as a semiconductor, as a supplier of the technology is concerned. In last few years, I guess this slide needs to be somehow, it's not coming properly. So let me try it again. So over the last few years, semiconductor industry has moved up to $305 billion market, and we shipped about 700 billion ICs last year, almost about 10 ICs, or more than 10 actually, 100 ICs per person on the face of the earth. And part of it goes to the fact that we wanted to make things more intelligent at very affordable cost, and making sure that devices are connected so that we can provide more intelligence across the board. An autonomous vehicle is the big part of that. Now, the pace of technology is accelerating over the last few years, and there are several reasons for that, and I'll try to refer to some of those in my next few slides. One is that the electrification of the car is getting more and more urgent and differentiating across the board. We can see that today more than 1/3 of the cost of the car comes from electronics in many cars. And this thing is even accelerating further. And as you know, number of connected cars have moved from about 9 million to about 24 million within the next couple of years, at least the expectation is. Also, we see that there is a lot of embedded technologies, and this chart on the right-hand side of the screen, you can see that the pace of adoption of semiconductor technology in cars outpacing the rate of the market growth in vehicles in general, which means that more and more electronics is getting utilized in the car for different applications. Here is a kind of example of how much electronics is already in the car and how electronics is changing the way that cars are being used and utilized, ranging from ADAS, which has been referred to, and power management, as well as all kind of sensors, with different aspects of the power in the car, from different voltage rails, 48 volt, 12 volt, regenerative braking, and all different advanced power management, which really requires high technologies and advanced semiconductor technology to offer a highly efficient vehicle for transferring power from one domain to the other, to ADAS, to provide these virtual displays in the car and heads-up display, which we are already addressing with our technology called DLP, or digital light processor. So we can see this presence is growing, and I was talking to one of the major car manufacturers, and today an average car has about 8,000 semiconductor device in the car, which is amazing how fast this progress is happening over the last few years. It's not just the car that is benefiting from a lot of these advances. We see that the infrastructure and the roads are amazingly adopting new technologies which used to be extremely expensive. Just to give you an example, we designed these vibration sensors which can measure the vibration of the pavement and can estimate the weight of the vehicle within a few pounds. So it's kind of equivalent to a scaling station, which used to be or is about $10 million at a few tens of cents, or maybe $1 at most. So you can see the way that the transformation of technology is happening, and the infrastructure ranging from intelligent signs to efficient ICT infrastructure, and of course wireless link. And on the other side, we see that extremely interesting advances in V2V, V2X in general, with DSRC and the new technologies that makes more and more connected car, as well as the power transfer between vehicle and grid in both directions. That's why we have a lot of innovations in industry on bidirectional power conversion at very high efficiency. Sensors. Sensor has been one of the hot topics, Internet of Things, but specifically in the cars, we see one of the major beneficiaries of the sensor technology is the automotive and intelligent vehicle. Sensor technology has been around for many decades. What makes it exciting now is that sensors are embedded in the IC. So it's a lot more affordable, a lot more accurate, and a lot more deployable in terms of the integration with the rest of the system. Just to show you what kind of sensors we are dealing with, the kind of list is very long, from magnetic, highly embedded magnetic sensors to vibration, to temperature, pressure, and all of that. And you can see in this chart that the growth in sensor market is extremely fast, and part of it is coming from the deployment in autonomous vehicle and, of course, personal communication. What I would like to highlight at the end is that we think the advances in semiconductor technology can really accelerate deployment of autonomous vehicle, whatever it means. And one of the challenges we have out there is the cycle of advanced technologies in semiconductor industry is a lot faster than automotive industry. So the question is, how do we synchronize that? In other words, by the time that the new model of the car comes out in the market, we have 2 generations of semiconductor devices already. And the question is how fast and how modular you can design the system to take advantage of these fast cycles. The impact of the intelligent transportation is not just technical, but also there is a huge amount of legal, economic, and social impacts are out there that needs to be considered, and some of them will be addressed in this panel. And at the end, when the cars become more and more connected, we are going to face the same problem of big data and security that we are all facing in our connected devices today. So with that, I conclude my talk, and hopefully we can talk more about it during the Q&A. Thank you.
Nice job. Thank you, Ahmad. Next up is Tim Yurden of Visteon Corporation. Tim is Vice President of Design, Marketing, and Connected Services for Visteon, based in Van Buren Township, Michigan. He leads Visteon's efforts to drive upstream customer engagement through user-centric design experiences and supports the electronics business expansion into the connected vehicle and services market. Tim?
Good afternoon, everyone. On behalf of Visteon, thank you for the opportunity to be here this afternoon. On the few slides I have, we're going to take a little bit different approach, a little bit more towards the consumer and framing this opportunity up. So you'll see a variety of what I call infographic slides. So in some of these numbers you had seen from the past panelists, but I really wanted to talk a little bit about the Internet of Things. And when you look at this opportunity, it is just massive. You know, $14+ trillion market by 2020. China massively investing in this area. Family of 4 has the potential to have over 50 connected devices in the year 2020. I mean, many of us are well on our way. $31 billion opportunity for those types of devices. And then in 2016, 2.5 wireless connections per person on Earth. Just some really staggering numbers when you think about this. And this is obviously beyond just the automotive space, but just the mass, the sheer mass is outstanding. Why does the vehicle matter? What's important for us in automotive or mobility, which is really the words we should be using as we talk about all this mobility integration for the future? Potential for a $30 billion market. But when you look down on the lower left, you see that $5 billion number for the potential in hardware. And you see the revenue or even the services over on the far or the top right, $20 billion in services. You see where these numbers, the world of traditional automotive hardware starts to flip. This starts to bring in new business models, new opportunities, the potential for big data. But how do we take big data and make it smart? How do we monetize that for the automotive space? There's a variety of analysts out there that have put bigger numbers. I have a number of $150 per year potential per vehicle. Some are bigger, some are smaller. We think there's a great value out there. FODA, firmware over-the-air updates. And thinking about that, with regards to warranty costs, where the future of warranty, 60% of this could be around software. And even if you look at that at $1 million per major event, these things are massive as well. And how do we start to solve these problems as an industry going forward? And some analysts have even predicted that out in the year 2020, software warranty alone in automotive could be a $100 billion issue. Big numbers. And then, of course, software security and the smartphone and the embedded phone win, according to various predictions. But the real thought around all these technologies, all these opportunities, all these events, really comes down to how do we design the appropriate experience in this mobility market. With some of these new business cases, use cases, mobility opportunities, your first interaction with a service or renting or leasing or using a vehicle for a part of time might be through your mobile device. So we have to make sure that app on that phone is designed accordingly. It's about the experience, but efficiency, the economics, the convenience, and the safety, all those things start to come together, specifically here at ITS. Then lastly, it's really about how do we bring this all together? How do we enable your mobility strategy? Many of us in this room are in the automotive industry. We bring a tremendous amount of what I call automotive intellect. We understand the architectures, we understand the software and the safety and the security that needs to be embedded in these systems. That's something we can't lose sight of. The global reach. At the end of the day, we have to mass produce globally, but yet we have to still regionally differentiate in our various markets around the world. And this is a very complex task. An open system approach, not just in the software or the hardware, but how do we collaborate with other technology partners? There's those that talk about collaboration and there's those that do collaboration. We have to be the ones that do collaboration. Cockpit systems expertise, this is really where Visteon's focus is. How do we design that human-machine experience in the vehicle as well as outside the vehicle, as I just spoke about? Proprietary foundational elements, really it's about connectivity at the core. How do we have and enable pervasive connectivity? And then once you have that, how do you unleash these opportunities and business models beyond the car? But we can't lose sight of that last thing, which is user experience and that insight. At the end of the day, very few of us go into the mobile phone store and ask for a device that has multi-point touch capacitive sensing technology. We go there to get a device that has an experience, something that makes our lives better. And that's the way we need to treat an automotive or a mobility experience. And the last thing I'd like to leave you with, it's really about thinking about vehicle connectivity and solutions that are designed to adapt to a future. In the future, there may be no SOP. There may not be a start of production for this ecosystem. It may be how do you constantly adapt and design to adapt to this changing world. Thank you.
Thank you, Tim. Up next is Jim Buskowski of Ford. Jim is a Henry Ford Technical Fellow and Director of Ford Research and Innovation. His 35-year career spans the growth of electronics in the automobile, and I think I've known you for just about all of those. His contributions include Ford Sync, My Ford Touch, and Ford's Common Electrical Architecture. Jim?
Thanks, Jeff. Well, good afternoon. Thank you for that introduction, Jeff, and thanks to Delphi for the opportunity to participate this afternoon. It's also kind of interesting to see how Jeff is able to keep those seats warm for us while we're up here speaking. At Ford, our future really starts with the vision of Henry Ford. Let me get going on slides here. Henry Ford's life spanned an era of dramatic change, and the vision changed the way we live. Today, that vision still is at the heart of what we focus on at Ford Motor Company, and it is at the heart of how we will evolve. And the future of personal mobility has emerged as the single most important factor in the deliberations at the Ford Motor Company today. We believe that mobility comes from freedom and progress. The future of mobility has wonderful opportunities and also significant challenges for everyone. Our job as technologists is to use new emerging technologies to maximize personal mobility while minimizing the challenges. So what's Ford's role? Well, so how does the vision of opening the highways change? It changes by connecting the highways for all mankind. Connecting is a critical portion to the future of mobility. So as we look at what the world will look like in the future, we already see that stitching together travel, where we change our transportation device to match the local requirement, is important. And it's connecting all those devices, whether it's trains, planes, cars, even personal transportation, even just walking. So being able to connect and stitch those together seamlessly to create an experience that requires very little effort. As Tim pointed out, the experience is what consumers are looking for, and a seamless experience that removes hazards, keeps things safe, keeps things smart, and is frictionless. Now, as we look out to that future, it's really a network of solutions. It's a combination that requires collaboration across many different forms of transportation. You know, by 2050, potentially a world of 2 billion cars will have a true network of solutions driven by big data, all connected and operating together. And the connectivity isn't just about the connectivity from cars to cars. It isn't about channels and pipes from cars to cars and the environment. It is about the data that transitions across those networks to create the experiences, the seamless, frictionless experiences. And so managing that data is how we are going to change in the future, how our businesses will change. And in that data, it really starts with data that is collected not only that is part of the environment, the traffic information and so on, but also by the cars themselves, which contain numerous sensors and numerous capabilities to be aggregated together for the benefit of all. So again, the tremendous amount of volume of information, the velocity of information, the variety of the information, the voracity of information has to be turned into real value for consumers. And so that's part of our vision and challenge and how it's going to affect mobility in the future, how we use this data to create better experiences. Now, partnerships, I mentioned about collaboration, whether it's in the US or whether it's in Europe or the rest of the world, it's going to be collaborations across all our industry. And here today we have a great representation of that collaboration with automotive OEMs, our tier 1 partners of Delphi, Continental, and so on, as well as technology partners like TI, and many other technology partners that can be small startups all the way to major companies that have been in the technology business for a long period of time. They all have something to contribute to this vision going forward. So if I look at the one thing that I think we need and really need as important in delivering the future of mobility, this blueprint for mobility, is our collaboration working together, effectively working together with making the experience for consumers the best it can possibly be as we face the challenges of globalization, of large growing urban centers and more cars on the road. Thank you very much. Back to Jeff.
Nice job.
Thank you.
Thanks, Jim. Yeah, Jim and I have both been in the industry long enough to know that you always try to find a seat just in case the music stops, because occasionally it does in automotive, right?
It's nice and warm.
Good. Okay, our next speaker is Kristen Tabor of Toyota. Kristen is Vice President of the Technical Administration Planning Office at Toyota Technical Center, TTC, located in Saline, Michigan. She oversees corporate direction of Toyota's North American Technical Center, as well as the technical direction of electronic systems for North America. And she's a major advocate for women in automotive engineering. Kristen?
Thank you very much, Jeff. I'm happy to be here today to share some of the thoughts of Toyota related to the next generation or future of ITS technologies. Toyota really wants, let me use my clicker. Toyota would really like to use these type of technologies as we achieve our ultimate goal of 0 fatalities and traffic accidents. These technologies actually create smarter cars and support drivers in having a more comfortable and safe driving experience. As you can see, we consider the whole ecosystem of people, vehicles, and the traffic environment when we're developing these systems. And we've been working very hard to create those products that will drive and help drive the future of this technology. From the graph, you can see our next big frontier will be the automated and connected technologies, and we know that these will have a significant impact in reaching our ultimate goal. Our overall philosophy or concept is of integrated safety. As I mentioned, we consider several stages of the driving experience, both from a parked state when you start, through normal driving, and then again continuing into, hopefully not, but in case of pre-collision, the actual collision, and post-collision. In each of these stages, we can develop technologies and have launched to the market technologies that will support the driver and allow for a safer experience. These systems allow us to look at the entire continuum, and automated driving technology pushes that frontier even farther. To demonstrate some of the potential advanced technologies, Toyota has participated with ITS in several of the World Congresses. We've shown our progression of introduction of these type of technologies, again, aimed at supporting the driver. We believe that this step-by-step approach for introduction will allow customers to gain a more comfort with the technology and build understanding and mutual trust and confidence in these systems and their benefits. This year, we're showing our updated highway driving assist system, which I'll talk about in just a moment. The safety, when we think about it, improvements start at the very beginning with mitigation from crashes. We use a more common or traditional approach in this stage of the driving, such as vehicle structures or restraint systems. However, we want to continuously expand that capability further and further to support that mitigation and, of course, ideally avoid the accident altogether. Many of the technologies, as we expand, are already in the market today, and we can see the contribution of those even today in our marketplace. These technologies, including advanced driver support and connectivity, can enhance the safety of the vehicle in that risk reduction phase shown farther to the right. The AHDA, or Advanced Highway Driving Assist System that we're showing, as I mentioned, is one of the technologies that accomplish that task. We're actually showing those systems this week on the public highways here surrounding the Detroit conference. This is a great example of our approach to the application of these type of advanced driving support systems. We combine the dynamic laser cruise control and lane trace control systems to bring a much more comfortable experience to the driver. However, at all times maintaining overall driver control of the system. We employ driver monitoring HMI. This tracks the driver's attention and awareness so that when we're ready to hand full control back to the driver in those more tricky maneuvers, we know that the consumer and driver is ready to regain that maneuver or that control. And finally, we employ a full preview type HMI system where we alert the driver even farther in advance to let them know that a tricky or strange or abnormal maneuver may be up and coming for them. This builds kind of a relationship between the vehicle and the consumer that allows the customer to feel very comfortable and safe, and again, build that trust component. We plan to launch this type of system in the very near future right here in the United States. This demonstrates, again, our ability to bring these type of technologies to the market. We want to emphasize that these type of systems are ready for deployment. Lastly, I'd like to touch just briefly on the V2X type partnership systems that we've been working on. It's very important for us to support and continue to support the communications band, the 5.9 gigahertz technology through DSRC. We believe that automakers and other industry partners need to continue this collaboration, both with our national and state governments, academia and research teams, and as I said, partners, to realize this future safer mobility. We fully support the DOT's initiative to progress this technology and the development in the United States. It's important that we, again, note we're ready to transition this from our research phase into the development and full deployment phase. Since we believe in this potential, we would also like to support the US DOT's effort in rulemaking and regulatory components to, again, further the deployment of these technologies. We really feel that these type of partnerships are the critical point to getting the technologies to market and to allowing the consumer acceptance of the products. In fact, as I believe was announced this week, we've furthered those type of commitments, working with industry partners, local academia, and the new Mobility Transformation Center. We're fully committed to continuing the research, the design, evaluation, and again, deployment of these type of systems. So we appreciate all of those type of partnerships as we move forward to launch the systems here in the States. We believe that these technologies will significantly move us towards that ultimate goal and future vision for our mobility. We want to achieve this state where there are zero traffic casualties due to traffic accidents. Our customers deserve to enjoy that safe and comfortable driving experience, and we understand clearly that this is the way that we can bring it to them. Thank you very much. Oh, excuse me.
Catch.
Thank you.
Thank you, Kristen. So I've seen some questions come forward, so please pass them to the end of the aisle. We'll get them collected, and we'll get them up here. So go ahead and start generating those if you haven't already.
That's what we like.
Next up is Frank Pollock of Honda. Frank is president of Honda R&D Americas Incorporated, that's HRA, and he's an operating officer of Honda R&D Company. Prior to this assignment, Frank served as senior vice president of Honda North America Services, providing operational services to Honda facilities throughout all of North America. Frank?
Go get him.
Thanks, Jeff. Hello, everyone. I've thoroughly enjoyed listening to all the previous presentations and all the speakers this afternoon. It's always very motivating to be reminded of how far we've come as an industry and to see all the very tangible plans that we have as we move forward together into this shared vision of the future for ITS. Our goal of a collision-free mobile society is within reach, and that's really exciting. The excitement comes not only from the implementation of these engaging and new technologies, but also from the meaningful impact it's going to have on society, and that means saving lives. Honda's focus on products and technologies that are clean, safe, and fun aligns directly with the goals of ITS. By continuing to expand our ITS capabilities, we can make our world cleaner and more fuel efficient, and we can make the road a safer place. And we can allow more people to enjoy the freedom of mobility. And we've heard that idea reflected earlier. But it's all about giving increased confidence and security while on the road. And of course, looking back, this aligns exactly with Honda's proven commitment to the safety over the years. We have a track record of not only protecting the occupants in the vehicle, but also for extending that protection to other road users, including individuals outside the vehicle. For pedestrians, we've conducted leading research with the development of the Polar 1, 2, and 3 dummies, as well as developed innovative frontal body structures. And while these passive safety systems don't prevent collisions, they help save lives, and they reduce injuries when the collisions do occur. And until we've reached our goal of a collision-free society, they're going to continue to play a vital role in pedestrian safety every day. We've also been leading the way in active
safety realm by introducing technologies such as our new collision mitigation braking system that warns the driver of an impending collision and automatically applies the brakes, as well as lane keep assist system, which helps keep drivers in the lane and on the road. As you can see, Honda has a strong foundation of vigorously pursuing innovative safety technologies. It's this focus, rooted in our foundation of safety and our shared goal of a collision-free society, that drives us every day to pursue the next ITS breakthrough. Now, I recently had an experience, a personal experience, with our lane departure warning system. Probably like many of you, you don't just drive one car, you drive many cars, the competitor cars, cars within your own lineup, etc. And I bring home different cars, and a lot of times I'm evaluating new technology. Now, the technology that I was evaluating that day was our new Honda Link technology, which was able to link up an iPhone to the display audio to show the maps and the music and things like that. Of course, I am not the best person to understand all the benefits of an iPhone. I guess I should, but my 17-year-old daughter is. She's fantastic with iPhone technologies. Anything you want to know, she knows. So when I got home, I asked her to drive the new Honda Civic Hybrid, which has all this link technologies, and I asked her to do it. And she went out and drove it, and she took 3 of her friends with her. And they went out to do something called driving and jamming. That's what they do. I'm not sure what it is, but I guess they turn the music up really loud and they jam. So they're driving and having a good time, and they come back in, and I'm in the kitchen, and I'm waiting for them to give me the report to evaluate the technology, and they said they love the Honda Link, they love it. But this little beeping thing kept going off. And I said, you mean the lane departure warning signal? That's what's beeping? And of course, all the friends start laughing, and they say, busted, we told you to keep your eyes on the road. And so the little beeping really warned her and warned the friends. And so I'm not really all that proud of my daughter's driving capabilities at this point and her skills, because she kept hearing that warning tone. But I was actually very proud of the technology, and it demonstrates how impactful it can be. And I was thankful it was in her vehicle, because that one intelligent technology, a warning, combined with the peer pressure, helped her to become a better driver. And I'm sure many of you have heard or experienced something similar yourself. Again, it's these safety technologies that create the excitement about the impact that we're going to have on society, or we're having on society every day. In fact, some of Honda's most recent examples of active safety technologies have already been applied to the most recently launched 2015 Acura TLX. We've expanded our collision mitigation braking system to now include autonomous emergency braking and pedestrian avoidance. In addition, we've added the road departure mitigation to take an even more active role to keep the vehicle on the road. We've actually combined our AEB with EPS to keep lane keeping assist to a whole new level. Now, if you're drowsy or distracted, or if your car gets a little bit too close to the solid lines, or if you have LCAS and you're approaching an off-ramp and the curve is a little bit too severe, this new feature will actually apply the brakes and steer you back into the lane to get you back in control of your vehicle. With these new intelligent technologies, we're expecting a considerable reduction in fatalities. And we're just getting started. We haven't forgotten about clean and fun. We've also been partnering with ITS Japan to conduct a pilot of even more technologies by combining traffic light technologies. I think I'm supposed to be doing this. Wait a minute. There we go. By combining traffic light timing information with onboard V2X communication information, we're able to help change the face of urban driving. Predicting traffic signal operation can help drivers experience the joy of driving while reducing time spent waiting at red lights. Nobody likes waiting at red lights, especially me. So additionally, fuel economy can be improved by minimizing stops and starts. We're looking forward to the adoption of these clean, safe, and fun technologies in Japan very soon, and having a very large impact on urban mobility. It's with this aim and focus that Honda is thrilled to be a founding partner in the Mobility Transformation Center right here in Michigan. We believe by uniting the key stakeholders throughout the industry, academia, and government that we'll be able to move with speed towards this new age in the auto industry. Now, looking towards 2025 and the future of ITS, there's a lot more in the works that we'd like to share with you. In fact, we brought these technologies right here to the ITS World Congress this week for all to experience. The first technology being demonstrated is automated highway driving. We're using live Detroit highways to demonstrate the automated basic highway functions. This car can merge into traffic, can maintain, it can change lanes, and it can exit the highway all by itself. This demonstrates Honda's vision for the future of automated highway driving. Now, several other technologies are being demonstrated at Belle Isle. We call this the omnidirectional safety system that prevents collisions with pedestrians, bicycles, motorcycles, and other road hazards, and features other world-first technologies. By combining V to X and automated driving technology, we're pursuing safety for everyone sharing the road. As you may have seen in previous demonstrations or announcements, we're able to warn the driver of a pedestrian, a bicycle, or a motorcycle in the roadway. And now, we're able to detect road obstruction, and by intelligent sharing of that information, automatically steer the vehicle around it to continue its journey. Another new technology is able to assist a driver in distress. If they're experiencing a medical emergency, this system can allow another vehicle to wirelessly tow the vehicle to help. This new technology introduces a completely different meaning of safety for our occupants. Not only will these technologies help prevent injuries, but if medical attention or other support is needed, they can enable fellow drivers to play a vital role. And I encourage all of you to take the time and the effort to experience these technologies yourself. We can explain it, you can look at a PowerPoint, but once you drive it, you really get it. So, looking even further ahead, Honda's big wish for ITS in 2025 is pretty simple. By utilizing the technologies we're discussing today, in 2025, we will have already taken a major step towards the goal of a collision-free mobile society. A society where our customers and everyone sharing the road can safely and confidently enjoy the freedom of mobility. Collision-free society. With that, turn it back over to Jeff. He's keeping my seat warm. Thank you for your attention.
Nice job. Thank you, Frank. Our next speaker is John Lochner from General Motors. John is GM's Chief Technology Officer and Vice President, Global Research and Development. He's also President, GM Ventures. It's a separate subsidiary which makes equity investment in startup companies that are developing next-generation automotive technology. John?
Thank you, Jeff. It's great to be here. But being the last of 7 panelists reminds me of the writer George Bernard Shaw, who once said, "The subject may not be exhausted, but the audience surely is." So I'm going to keep my remarks brief so we can get to the Q&A. Let me start by pointing out that it was on this date in 1966, exactly 48 years ago, when the original television series Star Trek premiered on NBC. Now, it would take much more than a 5-day conference to examine why Star Trek is such a cultural phenomenon, but certainly part of the answer is the 23rd century technology that featured so prominently in every episode. And what's really fascinating is the number of Star Trek technologies that are already in use today. A few examples would include communicators, which we know today as cell phones, needleless medication injectors, The current products currently use air pressure to inject medication under the skin. And three-dimensional teleconferencing. Have you tried telepresence yet? There is even an ongoing X-Prize competition to develop the first tricorder, that little handheld device that Dr. McCoy used to diagnose everything from allergies to zinc deficiency. Now, I'm not aware of any efforts to develop a transporter, but we're getting very close to another staple of science fiction technology, cars that drive themselves. The vision of automated driving goes back long before Star Trek. Of course, at that time, the technology to create automated cars simply did not exist. But now, intelligent and connected technologies are finally catching up to the visions of the past. In other words, it won't be long before all of us have an opportunity to boldly go where no one has driven before. As panelists, we were given a choice of questions to use in our remarks. Like some of my fellow panelists, I chose to make predictions about the world in 2025. So in the next few minutes, I'll tell you what I think intelligent transportation might look like in 11 years from now. Quite frankly, that's a dangerous assignment. As Yogi Berra said, it's tough to make predictions, especially about the future. So let me start by looking back 11 years to see what the world was like in 2003. To begin with, there were no smartphones, no Twitter, no YouTube, no Facebook, and no Kindles, Nooks, or e-readers of any kind. There were also no full-body scanners, no 5-hour energy drinks, no Google Glass, and no ice bucket challenges. My point is, things change often faster and less predictably than we think possible. With that in mind, let me offer a half a dozen conservative predictions, and I use the word predictions with some reticence. In truth, I think of these more as goals or targets, because many of the technology building blocks necessary to put automated vehicles on the road already exist. So what will intelligent transportation look like in the year 2025? Prediction 1. You'll be able to walk into almost any car dealership in America and buy a highway automated vehicle. In its simplest form, this could possibly provide for hands-off freeway driving, including automatic lane changes. This means that while driving down the highway at 65 miles an hour, you'll be able to enjoy a safe and relaxing trip. And who knows? You may even be able to manage your emails, eat breakfast, supply your makeup, or read the newspaper. In other words, you may be able to do the things that many people do right now while driving down the highway at 65 miles an hour, but you'll be able to do them safely. Prediction 2. For urban environments, you will be able to purchase a vehicle that is quite automated and perhaps fully automated in certain settings or situations. At this point, I'd like to address the difference between automated and driverless. This is not, I repeat, not a distinction without a difference. Driverless for us implies that there's no role for the driver, and the vehicle all by itself will be able to handle 100% of the driving situations and do so with flawless reliability at all speeds and in all conditions. Both the 100% of situations and flawless reliability describe the standard that we hold ourselves in vehicle safety because lives are at stake. There's still a lot of work that needs to be done to create the technical, legal, and regulatory enablers that will allow driverless cars, except, of course, for special use and low-speed restricted driving environments like those that are addressed by our NV2, which is shown in the picture. In other words, for the foreseeable future, a driver will still have a role, but driving will get easier and safer as new technologies find their way into the vehicle. The path to realizing a fully driverless vehicle is likely to be an evolutionary one with many stages, each requiring painstakingly diligent and thorough work. So my crystal ball is still too cloudy to predict when all of the technical, legal, and regulatory enablers will come together to make deployment of driverless vehicles a reality for most of us. Maybe at the next ITS conference, my crystal ball will be clearer. Prediction 3, a significant portion of vehicles sold in the US will have V2V capability, meaning they will be able to communicate with similarly equipped vehicles in their vicinity. In fact, I'd estimate that perhaps as much as 25% of the overall US car park will have V2V capability by 2025. Prediction 4, your vehicle will be able to identify and avoid pedestrians and bicyclists when they use cell phones that transmit their location, speed, and direction. This will actually address a very important challenge for our industry. Although total US traffic fatalities have declined over the past decade, the number of deaths involving pedestrians, motorcycles, and bicycles have increased in recent years. In fact, taken together, these three groups accounted for nearly 1/3 of all traffic deaths in 2012, the last year for which final numbers are available. Prediction 5, virtually every new vehicle sold in America will connect to your phone or other personal device, to your home, and to your place of work. And of course, the connectivity will be much faster than it is today. By 2025, for example, we'll be streaming live video in 5G, which will make today's 4G seem pretty pedestrian. For those of you that doubt that a new generation of cellular will be a reality, you should know that early discussions of the technical specifications for 5G are already underway. And by 2025, who knows? By then, we may even be talking about 6G. And prediction 6, we will be accelerating a host of ongoing efforts to build or convert existing roadways to intelligent infrastructure. Highways will be first, followed by a growing number of clearly defined environments, such as corporate and college campuses, government facilities, and eventually city centers. This in turn will lead to an entire new sectors within the auto industry, an ecosystem of mapping services, software developers, electronic suppliers, smart grid designers, and so on. Now, as I said a moment ago, these are really goals or targets as much as predictions. What we need now is a commitment and the will from all stakeholders, from automakers and technology suppliers, to government and academia, to make intelligent transportation a commercial reality. As Mary Barra said yesterday, no other suite of technologies offers the potential of intelligent transportation technology. And if we work together, we can turn that potential into reality sooner than many think. My unwavering prediction for the future of intelligent transportation is this: the transition from traditional to automated driving will be as important for our world as the transition from horses to horsepower. It will literally change the way we live. And how many industries can say that? What comes next will come from the people in this room. It's exciting. It's inspiring, and I look forward to working with you to make it happen. Thanks.
Well done. Okay, well said, John. So we have some questions already. Please keep them coming. We're going to have about an hour here for Q&A. So we'll get to as many as we can. But you can imagine they're coming in on some common themes. So let's start with semiconductors. Ahmad, if we could apply your brain and then get input from anybody else on the panel that's comfortable here. What level of computing power will be needed in 2025 on the vehicle? Will it be general instruction processes or a series of special purpose computing chips for image processing, natural language processing, GPS processing, et cetera? And then further, how can advances in semiconductors accelerate intelligent vehicles and the future of intelligent vehicles and roads?
Okay. Yes. A great question, actually. As you can tell from the advances in semiconductor industry, for last 4 decades, we have been doubling the power of the processor almost every 18 months. There are some challenges ahead of us. Of course, we cannot go exponentially forever. No exponential trend can last forever. But we see that the trend toward having more processing, and especially for automotive applications, we think that a new model of the hierarchical processing may address the problems more efficiently. Rather than having one giant processor handling everything in the car, most likely it's going to be a set of processors who are connected to each other with high-speed links, and collaboratively we can handle the different tasks. Because the number of sensors in the car are growing so rapidly, and the amount of processing is becoming so dominant in the sense that the number of cameras, radar systems, right now we have radars in 77 gigahertz on a basic CMOS. The size of the chip is about a couple of millimeters on each side. And we have laser radars, LiDARs, that is now being implemented. And all these information needs to be coordinated and combined, what we call it sensor fusion. So expecting one processor to handle everything is going to be a big challenge and maybe not the best architecture. But on the other hand, we think that all these sensors have some local processing power to process the data and to provide the information to the next level of processors rather than expecting to send the raw data because of the bandwidth efficiency and power efficiency. So just to summarize that, we think semiconductor technology has a lot to offer. It's not just the processing power, but having more efficient sensors, better high-speed links that connect these sensors together, wired or wireless, and offering a hierarchical structure to process this data more efficiently and offer these redundancy requirements, which is critical in automotive applications.
Good. Yes.
I think I agree with your comments, by the way, and I think the interesting discussions we're starting to have with many of our customers are not how do we design the future product to the spec and what it needs, but how do we design for that unknown, as I mentioned? How do we design to future-proof it? And that's a change just from 2 or 3 years ago. And I think it comes a lot with the processing power, and it's not only it's the graphics side as well as everything else in between. So it's a change of discussion, which is great for us in the industry.
Jim?
I'd add to that, the processing capability is going to continue to be, and the architectures on the hardware side are going to continue to be great enablers. I think the algorithms and the software are still key as well too. And I think we'll probably see a lot more of software and hardware being designed and thought of together as opposed to independent, moving some software algorithms and so on to hardware for improved processing speed and so on. But the secret sauce, though, is really being able to get the software right and accurate and reliable the first time. And software is definitely designed different than hardware. And so I think both of them together are really key to success.
Anybody else?
Jeff, I guess I'd like to offer that the cost of processing power today, the cost of sensors today are not going to support widespread deployment of a lot of the technology that we've talked about. We need basic order of magnitude improvements in the cost of some of these sensors, short-range radar, long-range radar, and so on and so forth. These things need to go down to the cost that you'd see for a typical CMOS design, which might be $40, $50 a sensor, not hundreds of dollars the way they are today. And surely LiDAR today, a typical unit, I won't name the brand, but a typical unit that we all know is upwards of $25,000. Sure enough, there are companies working on lower cost sensors, But the cost of sensing and the cost of processing power is going to have to move down a lot if we're going to make a manageable and a large-scale deployment of autonomous automated vehicle technology over the next few years.
Well, fair points across the board. It's several of you mentioned getting in sync with the consumer electronics world, getting in sync with the digital curve. And the key to cost reduction is getting as close to that digital curve as you can get, right? And still make it automotive grade. Still have time to validate the silicon, Jim, to your point, the software to automotive grade. So what can we do to better synchronize those cycles? They're getting better. Clock speeds are close. But technology's a little dated when we launch the vehicle. And then you bring up the subject of how do you future-proof? So what are your thoughts?
Well, I think that from the standpoint of automotive developments themselves, the frame side or the engine side or the powertrains are so much, they take so much more time, and the consumer electrics are changing over so much more quickly. We have to develop platforms that are easily updatable. And then once they get into, and they have to be separate, a separate development itself. And then once they get into the consumer's hands, they have to be updatable once again through over-the-air updates or other methods where we can continually update the firmware, the software, as you had mentioned, that's so critical to keep the vehicles relevant in the changing pace of technology.
Yeah, actually one of the most interesting trends we see for last several years is that automotive was not necessarily the early driver in the past of some of the latest semiconductor technology, but it's changing quite fast. We see like LiDAR that you mentioned, actually John mentioned, is a good point. Right now, if you want to buy a standalone LiDAR is from some companies about $20,000, and we are working on technologies which is driven by automotive industry to bring it down below $100. And that is by integrating light sources on CMOS technology, some really leading edge technology which is driven by demands in automotive. And kind of the change we see that automotive now is driving a lot of advanced technology developments in semiconductor, which is a new trend and very exciting. Unlike consumer product, which is like 18-month cycle of new product, next smartphone comes in 2 years. In automotive, once you have a leading edge technology, it's going to stay there for a while.
I guess the other thing I'd add is we really need sensors that have been designed from scratch with automotive in mind. When you look at today's sensor technology, you look at the specifications of a typical sensor, you find that it really doesn't match with what it is that we need to do. That means that we have multiple radar units on our vehicles. In fact, one of the vehicles that we show at our demo on Belle Isle actually has 6 LiDAR sensors. It's not the rotating mirror type of LiDAR sensor, at least the classical rotating mirror type of LiDAR sensor. But the point is that what we need are sensors that have better characteristics that are more suited for what we need to do in automotive than sensors basically that were designed for a different purpose and somehow can be repurposed for automotive, but are far from the kind of sensors that are really optimum for what we need to do. I'm sure there's at least one session with all of the technical sessions where they're going to get into some detail as to exactly what the characteristics are of this new class of sensors, but make no mistake, that needs to be done as well.
Ralph, you started to say?
Yeah. We have really analyzed what's the difference between the cycle time in the CE industry and automotive industry. And interesting is the conclusion is there is no difference in speed. Because if you see what our engineers in the automotive doing compared to CE, they have the same speed. But the issue is, if you are ready with development, you need to make sure that it's in each and every circumstances working. Just only for information, as soon as you are sitting in a car, we take responsibility for your life. That means the software and the systems always needs to work perfectly. If you take out a CE device, a smartphone, yeah, this is not always perfect working. You have resets, you have hangs. And keep in mind, you would have resets and hangs in your brake system. And that takes time. Give you a comparison in data. The basic functional development takes us approximately 12 months. And another 2 years, we really need to make all these tests to make sure that the systems in each and every circumstance is working and even to protect your life.
Another thing I'd add, and it's kind of a parallel technology development, and that is in the area of tools. And I know we have represented in the exhibits Siemens and MathWorks and so on. Those are going to be absolutely critical, and just, it's almost paralleling what happened in the semiconductor industry. I'm sure that some of your longtime semiconductor designers couldn't possibly imagine 30 years ago what we do today, and it wouldn't be possible without the tools. And so it's really important for us in the automotive side to be able to develop those tools at the same time, whether it's for automated driving, whether it's for other functions. Those tools are going to be critically important, even in the area of HMI, human-machine interface.
Yeah, it's not been that many years ago when we all celebrated first silicon working coming out of the fab, an unthought of opportunity, and now it's done routinely. We need first sensor, first electronics to come out, first software to come out, and it works. It's automotive grade and ready to go, right? That takes the cycle time out that you talked about.
Right.
Yeah, I don't want to pile on here about the sensors, but in order for us to democratize this type of technology and bring it down to lower levels of vehicles, the sensor costs are going to have to be reduced. I mean, that's something that's going to impact everybody, right? And the customer can't just bear that cost. So, in order for us to guarantee the quality of the experience or the safety of the individual as we introduce highly automated highway driving, we have to guarantee a lot of sensors, right? And a lot of inputs, and the cost of that's going to take off. Now, in 10 years, I don't know what that looks like, but we have to put plans in place in order to keep the cost down.
No, fair point. Now, I have noticed that the sensors being too costly conversations coming from the OE side of the panel here.
Yeah, I noticed that.
It's not coming from the supplier side.
Well, since we don't make sensors, this is why I'm so bullish on V2X. I mean, when you think of, not that it's going to supplant or eliminate the need for these sensing technologies, but when we think of that from a roadmap standpoint, V2X definitely enhances that opportunity to reduce that dependency down the road on all these sensors that are coming into the vehicle. So it's
no doubt the cost is going to be a barrier for whatever technology enters the vehicle, and you've got multiple sensors. You're going to democratize. It has to be affordable, right? The price of vehicles can't go up. Consumers won't pay more for vehicles.
Just a quick comment on sensors. Actually, as you can see in the semiconductor industry, this exponential growth didn't necessarily happen in sensor market because sensor is a mix of electromechanical and electronics, and one of the inflection points we see in high-tech industry is that a lot of those sensors are now becoming like a silicon development. In other words, become on-chip sensors, and hopefully can take advantage of the same level of productivity and cost reduction we see in ICs that is now exponentially going down. For example, magnetic sensors or current sensors or things like that, which used to be a separate unit and a kind of bulky, now it's becoming part of the chip. You have a magnetic material spotted on a silicon and becomes a current sensing or magnetic sensing or vibration sensing or ultrasonic sensing. And hopefully within the next few years, we see this price reduction comes from the fact that same approach we did in semiconductor fabrication is going to apply to some families of sensors, which makes it quite exciting.
Okay, let's switch gears here a little bit. Jim, this is specifically for you. But I think it's a fair question for anybody on the panel here. What impact does connected vehicle and ITS have on product development inside of Ford or the OEMs, either from an OEM view or a supply view? Systems engineering, for example.
It has a huge impact because it really requires us to break down the barriers between different parts of the organization. And I think you have to start thinking about connectivity and connectivity experiences and so on. Always, anything we do, we really have to think of from the consumer's point of view. What kind of experience are we going to create for the consumer? And these experiences are going to be dependent on lots of organizations that never really had to work closely together, have them work together very closely and integrally and exchanging information and having a uniform approach of doing things so that they can deliver something to the customer that that is seamlessly integrated. And that's true for both inside our companies and outside as well too. You know, as we integrate the vehicle with the environment around us, we have to make sure that we're breaking down those boundaries and finding seamless ways to collaborate as well. And with regard to systems engineering is a topic all in itself in terms of really moving from a component headset, looking at individual parts and gluing parts together, to how do you optimize the system. You know, Tim mentioned about V2V, V2X, and how we can replace sensors and so on. We're really looking for, with systems engineering, the optimal solution that provides the best value for the customer. And again, that's working a lot across disciplines and finding new tools that help us figure out what that optimization is.
I couldn't agree more. At Toyota, as I think I mentioned, we look at the kind of holistic approach to the driving. And as Jim mentioned, you know, you have to cross the boundaries and merge those systems and see where the overlap is at in order to expand the reach of the output of that system and then its influence for the consumer. So the systems engineering is becoming one of the biggest new areas that we're having to deal with, where previously you could kind of self-contain and design a technology. It's how those technologies work together, and then again, how they interact with the consumer and how they overlap and expand that capability to reach further and further away in the whole driving experience.
So do you think you folks have it figured out? Does Ford have that figured out? Does Toyota have that figured out?
I think it's an evolution. So that'll continue to change as the technologies change and the capability of the technology gets further and further, and the interoperability between the systems will continue to grow. It'll continue to expand. So I don't think we have it all figured out, but I think we're figuring it out.
I agree. I think we continue to make a lot of progress in this area. There's still a lot of work to do because it has been, you know, a strong tradition in the past to be very component focused. And so tools are helping us, education of our engineers, bringing our engineers up with a mindset around a systems approach to things. And so there's still a ways to go, but I think we continue to make good progress. Electric vehicles are a good example of very strong systems engineering disciplines.
Anybody else?
Well, I would say one of the things that I think is going to be most profoundly impact is the electrical architecture of the vehicle itself. You're going to have a lot more sensor inputs. You're going to need to use the so-called sensor fusion approach to build an integrated map. You're going to have commands being given potentially to steering systems, braking systems, acceleration systems. This is all going to have to be done very, very fast. And so at some point in time, you have to look at your electrical architecture and say, hey, is this kind of electrical architecture I can ride into the future, or am I going to have to make a change somewhere along the way because I'm not going to patch my way to a system that's really going to do what needs to be done. I think cost is going to be an issue. How much and what is the configuration of electrical architecture to optimize cost, recognizing you're going to have luxury vehicles that are probably going to have more active safety, autonomous driving features than lower level ones. You're going to want to figure out how to avoid putting unnecessary cost into a huge amount of vehicles just to enable the capability in a relatively small number of vehicles. And I also think that more and more we're going to have to look after the whole cyber vulnerability of these things. I'm not aware that there have been tremendous hacking incidents with people hacking into the electrical architecture of vehicles, but as we become more and more connected to the cloud, vehicles start exchanging information. We got to lock that thing down because we are talking about safety systems, and we do need to take care because there are always people out there that have different ideas about what they think they want to do. Yeah, I'll just leave it at that.
The only thing I would add to that is the current way that we do development, when we think about V2V or V2I as we move forward, must change. Because of the fact that we currently emphasize, of course, the quality, the durability, the robustness, the safety of the systems. And we have to anticipate all the ways that the vehicle and the customer uses the vehicle. And now we're going to open up to an almost infinite amount of change points that we have to quickly react to, and we have to react into our development cycles. So as soon as we learn something, because it's a constantly moving landscape, as soon as we learn something, we're going to have to reflect that back into our developments itself. So that's why I mentioned earlier, we at Honda are considering a parallel path type of a platform system infrastructure that we mature it in a parallel path to the actual frame side powertrain development. So we feel like there will be a pretty significant impact in the way we develop those integration of systems.
Okay, more software, more systems engineering. John, I'm with you. I think we're in for a radical change in architecture. From the days of thinking of that as a physical delivery of amperage and current is well behind us. We're looking to the future. It's functional delivery first, physical second, and that opens up big opportunities. Okay, speaking of opportunities, let's talk about business models. You all think about this, you all jealously guard your P&L as you should, but there's also a lot of people envious for this space that we all occupy called automotive. From the consumer world, many different aspects. So here's the question. Will ITS transform the business model for automakers or suppliers?
That's an
I'll take
or
that.
question.
Will ITS transform the business models for automakers or suppliers?
Or suppliers. It's not an and, it's an or.
It could be
right.
it's written as an or, but it's an and.
Here we go.
All right. Well, hopefully it's an and. So, you know, with that, at Visteon, we're starting to see three speeds evolve out of the business. One is the hardware side and the development speed of the hardware. The second is software. I'd say we're in that phase today. In the future, not disregarding the previous two, is going to be around connected services. And when we get into those connected services, when we have pervasive connectivity on the hardware side, then what do? That's where all these new business models come about. And I think that's where, you know, with the carriers, with ITS, with our OEM customers, that's where all this collaboration has to take place to define those business models and how you're going to make money at it. And obviously there's a security component, there's what I call the B2C side, and then there's the B2B side for us, which I think is more important for the supplier side and the Visteons of the world. What do we focus on the B2B?
So you're going to make more money or less 10 years from now?
Hopefully.
One way or the other, we're going to make more money.
Would anybody,
but on services, hopefully.
Would anybody admit to desiring less? Of course not, right?
Look, I would characterize it this way. I mean, we need to talk about, you know, the nature of the question. Are we talking about just service revenue, or what are we talking about here? I think there's no doubt that the electrical content of a typical vehicle is going to go up dramatically, okay? Depending on what type of supplier you are and what your area of expertise is, there's going to certainly be opportunities as the content of the vehicle goes up. We've talked about additional sensors. We've got all sorts of changes that are going to take place in terms of these systems, acceleration, braking, and so on and so forth, control systems. I mean, this opens up a lot of opportunity to really change the game. But it's all going to be built around sort of the disruption that's going to take place as we move from sort of the analog, manual type of systems that we had in the past. We're on the march now to full digital systems, lots of control, lots of capability, and that's going to open up a lot of opportunities. Again, depending on where your area of expertise is, you may view this as a blessing.
Yeah.
If it happens to be where this thing is headed is not in your area of expertise, then you'll hardly be applauding, will you?
But I thought it was very interesting from your presentation that you said 10 years ago, we didn't have a lot of these things, right?
Exactly.
So we didn't think about apps or new smartphones or connectivity the way we think about it today. And I think from a business model standpoint, currently, you know, OEMs are heavily dependent upon tier ones. But in the future, I think that there's going to be opportunities, or there needs to be opportunities for flexibility. We've put pieces in place now, like for instance in our Silicon Valley office, where we're trying to find emerging technologies and sensing to where the market is going. And then by utilizing those, one of the big obstacles we find is that if you find some emerging technology, you need to marry up with a partner quickly to scale it up so that you can use it in manufacturing. You know, it's one thing to have somebody in a garage, you know, making something, and then there's another thing to have a factory making 1,000 cars a day. So, you know, that scalability is a big issue. So in the future, there's got to be some partnerships for new emerging type businesses to marry up with existing businesses that can supply the manufacturing industry. So flexibility is key, I think, for us.
I would answer it a little different. Looking on today's business model, and a car manufacturer sells a car, a supplier sells component to the car manufacturer, and he make out of the components a car. This will not change. But other business coming around. So the question is, to whom in future will the car manufacturer sell the car? Is it individual persons, or is it rental company, or whoever is it? Second question is, so what is the consumer doing with the car? Then we come up with business models like Uber. Third element is suddenly other industries enter the automotive industries. See, Google have shown up a self-driving car. And the fourth element is, if we take it serious, coming along with ITS, really new businesses are coming in. So in summary, the business model, there's one party doing cars, the other one supplying components stays, but around that, a huge new complexity and variety on business models will shining up, by the way, including new players.
Just a quick comment I would like to make. Of course, asking a business question from CTOs is a tricky business, but in general, I mean, there is a value chain of car OEMs and suppliers and electronic industry, but the bigger picture, I think, is going through a bigger change. I mean, what we see in Silicon Valley, for example, is that car ownership for new generation is very different from old generation. A lot of kids prefer to have a smartphone than having their own car. And many of them are using these fancy buses to the work, which is like a working environment on the wheel, rather than a kind of car that kind of gives them a sense of, you know, horsepower and torque and all that stuff. So what's going to happen to the whole society and the concept of the car in next generation is a bigger question, which is, we can see some changes is happening there. I'm not sure exactly which way it's going, but definitely it's changing.
I think, and Bill Ford mentioned this morning the same thing, our jobs are to make people's lives better, right? And when we make them better, they'll pay for it. That's what they value, that's what they'll pay for, and we need to figure out, if we're mobility companies, for a mobility company, how do we make people's lives better through mobility, getting them from where they are to where they want to be. And yes, it will adjust some models, business models for all of us, and we'll have to adjust accordingly.
Agreed. The business model is changing because mobility is changing. So the whole foundation, as you mentioned, you know, the previous model of selling the car or the supplier selling us parts, that's not where the story goes in the future. So there's lots of other transactions that occur in that model of the future, and so obviously we have to adapt and evolve to that new business model. And as you said, the consumer is going to drive that. What they value is what will be valued and how the model will be set up.
Fair enough. Okay, let's do a speed round here. I'm going to ask you a question. I'd look for a 1 or 2 word answer, if you could, from each of you. We'll just go down the panel. Ralph, I'm going to start with you here, just to warn you. Okay, so let me set this up. We talked about some of the benefits. Several of you did in the Q&As during your presentations. We certainly heard it from Bill Ford and Mary Barr last night. But for you, what's the single biggest benefit of ITS technologies? All right, and I know ITS can mean different things to different people. We've already talked about that. Is it less gridlock? Is it better fuel economy and less emissions? Is it less accidents, less fatalities? Is it mobility for the physically challenged? Is it something else? 2 word answer, best you can. Ralph, biggest benefit of ITS?
Making the planet a little better. Precisely 1.2 million fatalities, which we have today, is completely unacceptable. Environmental issues are unacceptable as well. And by having ITS, we should have no more fatalities anymore and clean air. And this is to make the planet a little better.
Okay, so I'll take that as 2 answers, but close enough.
I would
Come on.
say safety, productivity improvement, and improve quality of life.
Okay.
More than 2 words.
That was sweet.
That's 3. We're going the wrong way here.
We'll get it back on track. Pervasive connectivity.
Pervasive productivity. Jim.
Safer, smarter mobility experiences.
Kristen.
Improving the safety and sustainability of mobility.
Okay, you guys are cleverly combining a couple in here. I get it. Frank.
Collision-free.
Collision free. John.
Cars that don't crash.
Cars that don't crash. That's pretty simple. Okay, on the speed round. John, I'm going to start with you on this. So we talked about the benefits. You talked about what you favor here. What's the biggest barrier to getting these benefits, to getting these technologies on the road? Is it regulation? Is it technology? Is it privacy? Is it cost? Is it infrastructure? Or something else? John.
Today it's cost.
Cost. Frank.
Say standards.
Standards. Kristen.
Consumer acceptance.
Efficient collaboration.
Efficient collaboration. Okay.
I was going to do acceptance, but along with that is, integration.
Okay.
Today's cost, tomorrow is adoption of new technology.
Cross-industry collaboration.
Okay. A lot of calls for collaboration, a lot of calls for alignment. That's really what the ITS World Congress is all about, right? So that's a good call to action here. Okay, let's keep going. This is a data set of questions here. I'll try to put this together. Maybe we can put this together in one chunk of questions. A lot of businesses want to access the car data and are saying consumers own all that data. Who do you think owns the data? And further, in the world of cybersecurity, do you see the need for a car software update to protect against hacking and data access? Who owns the data? How do you protect it? Anybody?
Consumer owns the data. There are working collaboratively with the IT industry and others to leverage the best security methods possible is what we need to do.
I'm not a lawyer, but I think there are privacy issues that no doubt have to be respected, particularly when the data flows to unknown parties beyond the automotive manufacturer that perhaps could collect it.
Regarding the cybersecurity, definitely some rules or protocols have to be put in place to avoid some malicious intent. Something has to be addressed there.
Agreed. I'd say the consumer owns the data. However, again, I think we have to respect the laws that are developed to protect when that data is exchanged knowingly or unknowingly beyond the consumer and their partner with the OE.
Consumer, but I think the interesting piece of the question is the updatability. I think that's the challenge for all of us, from an architecture on the vehicle side to a delivery method from wherever it's coming from, and how all those software pieces, whether it's security or other, is managed accordingly. That's a huge challenge.
Anybody else? It's interesting. The consumer owning the data seems to be the consensus approach here. Makes sense. A Harris poll I just read over the weekend said that 65% of consumers are worried about the privacy of their data in the automotive environment, but yet we'll all opt in on this many different times for many different apps. So is the play to get an opt-in for data access in return for safer vehicles, more productivity?
Well, I think consumer owns the data, and we have to help the consumer understand the value of that data. And then they can make the choice on opting in. In the end, if they see it as value, certainly we got to create the trust and put the infrastructure in place to protect it. But ultimately, we also have to help them see and get the full value out of the data. And then they can choose.
Fair enough.
Yeah, I would echo that completely. The value proposition for the consumer is key, because who would have thought 10 years ago that I would pick up my phone and tell somebody where I am so that they can route me to another location, right? But unless they know where the destination is, they can't actually do that routing. So in the future, what are those value propositions that we're going to be able to give to customers When we talk about V2V, you have to broadcast your location in order to tell others where you are, and also to improve the safety of yourself and your family, or occupants around, or other vehicle occupants. So once that value proposition becomes more understood by the general consumer, perhaps this will expand more and more.
Anybody else?
Yeah, just to add on, you know, I come from Germany, so privacy is a very special issue in Germany. But understanding the internet industry, their business model is around private data. As more private data they have, as better business they have, because they do not have any kind of hardware. And that's very much different in the automotive industry. For us in the automotive industry, data helps to make the customer experience of the car better, but it's not in the core of our business. And so I understand we are treating in the automotive industry this issue completely different from the internet industry. Means, Jim, as you are saying, the data are owned by the consumers and privacy is totally respected. It is very much different from the internet industry.
Fair
You know,
enough.
if I could say one more word on that, I think the trust, you've heard trust and so on, is important. And I think in creating the value, creating the opportunity, you have to have transparency. I think if you give away data and you really don't know how it's going to be used, you're not going to trust the situation. They may give you some value for it, but if you don't know how it's going to be used, you're not creating a system of trust. So transparency is going to be very important.
Yeah. Okay, several of you mentioned standards and industry alignment. So let's ask the question this way. Will standards and regulations lead or follow market implementation? Lead or follow?
Yes. I mean, in certain cases, look, in certain cases today, the existing regulations that we got on the books are fine for some of the active safety technologies that we got, okay? So there isn't anything that's holding us back from, as OEMs, from offering certain types of safety technology. I think the question really drives to the point of when we start talking about interoperability, which is the story of getting value out of V2V and V2I. That is, if the General Motors vehicles won't talk to the Hondas, they'll talk to this stretch of interstate, but not that, we're going to be completely screwed up here. That's the part where we need to collaborate. Potentially, we need a standard so that not only the auto manufacturers follow the standard, but everybody else follows it as well. And that leads us into this whole idea that we're working at 5.9 gigahertz in terms of this band that we're going to use for this so-called DSRC, direct short range communication. I mean, we all have to be working on exactly the same band, exchanging information the same time, the same number of times per second, the same data, location, speed, direction, whatever. Because if we don't do that, we're going to wind up with a balkanized mess, okay? In fact, you know, I've been through the electrification story. And this whole story of interoperability as we talk about V2V and V2I and so on reminds me a little bit of charging infrastructure, okay? Where everybody's putting up their own different kind of charging infrastructure. This is what we suffered with for years. SAE was good enough to put together one standard, the famous J2902, or 2901, I forget. But anyway, they put together the standard that basically governs 110 volt, 240 volt, and DC-DC charging. Everybody will have the same charge port. You can, you know, basically have the same connector style to hook to the charge port in these vehicles. This is the way we got to go. In an analogous way when we start talking about V2V, V2I, and a lot of other things.
As an industry, we love standards. As an industry, we go a lot faster if we can design
He
the
mentioned
standards.
GM talking to Hondas, which is exactly true. You know, how we talk to each other obviously has to be standardized, but the other issue is what's going on with the infrastructure itself. If we, you know, it's all well and good for Michigan or Detroit to have an infrastructure that's smart and allows communication with cars, but what about the neighboring town? Or what about the neighboring state? or some small little village somewhere, or in the middle of a highway or something like that. So from an infrastructure standpoint, we all have to work together. It's not just vehicle to vehicle, it's also vehicle to infrastructure to provide that umbrella. And I don't know where that standard or the mandate for that change is. I haven't heard it yet. I don't know whether there is one coming. You know, so that's something that we're still kind of waiting for.
So you mentioned that we love the standards, but I think the standards are really necessary for us to guarantee the quality to the customer. If we don't have that, how can we make sure, as we said, that it's always going to talk when the system is available, or that we're always going to communicate? It's one thing to have the system be able to talk inside itself, but once you reach outside the vehicle, the number of variables are just too big. So we have to have those standards to ensure that the communication is always reliable. There's no way we can go to our consumers and have the excuse of, oh, you know, they didn't use the same communication protocol, so you couldn't see that vehicle or that sensor. That's not an acceptable condition for us. So.
Anybody else?
I think a standard, of course, is required for interoperability, but the challenge is how to keep them to minimum, because the standard process is such a slow, long process. By the time you go through this process, there is several generations of technologies already that makes the previous decisions already obsolete in terms of technology compared. So the challenge we have is standards are required, but how to keep them to minimum to provide interoperability rather than taking it all the way down to every details, because technology is moving a lot faster than the standard committees.
Okay. We've got about 10 minutes left just to put it in perspective here. John, you talked about cost. You talked about bringing technology in on the premium end of vehicles, and it filters down as it comes down the cost curve. From many aspects, a lot of the ITS technologies, Frank, your experience with your 17-year-old, for example. Here's a question that's kind of geared right at that. Auto companies introduce new technology in luxury cars, which are often bought by people over 50. I resemble that remark. And less technology oriented. Why not change this and create a new vehicle model called a millennial, focused on the 20 to 35-year-olds?
Well, I wouldn't say that we're targeting a specific age group as much as we're targeting a specific type of buyer. I mean, luxury car buyers tend to be the ones that want to have the first on the block sort of claim. Look at my brand new car, look at what it will do, and so on and so forth. They tend to have the highest amount of purchasing power. And let's face it, this advanced technology always, I don't care if we're talking electrification, active safety, whatever type of technology you want to talk about, at the beginning, it's always with a cost level that's much higher than we'd like it to have. But you got to start somewhere. So you start with the buyers that are most willing to pay for this advanced technology, that see the most benefit for the way that they use their vehicles from advanced technology, and frankly, they have the means to be able to afford to buy it. And then as you build scale, you have generations of improvement in the technology, whether that's sensors, processing power, you name it. We go through some generational improvements, we drive down the cost curve, then you can support widespread deployment. But I don't see how you can go into the bottom end of the market with, let's say, an active safety package that's $3,000 when the absolute price of the vehicle is $15,000, and wind up with a lot of people being able to afford it, nor actually choose that technology over a lot of other choices that they have to make in their vehicle. Does that make sense somehow?
It makes economic sense.
Yeah, we you know, obviously when you introduce new technologies, the volume is low, and so the cost is high, you know, basically. So therefore you give it to the early adopters or somebody who can pay for it. We at Honda are trying to put that on its head, trying to reverse that trend. I don't know we're doing such a great job of it right this moment, but our intention in the future is to try to democratize that type of technologies by identifying set volumes in advance, and not just one specific vehicle, but maybe over an entire platform. And we've announced that with different suppliers and such, where we might be offering up 2 million units of something as opposed to 30,000 or 50,000. And in that way, up front, perhaps we can say, or we can introduce those volumes and those efficiencies that come through that scale and apply the technology at a lower level to a customer that might want it a little bit more. Like you mentioned, if you're over 50 or 60 or whatever, perhaps you're not an early adopter of iPhone technologies. I think I mentioned that earlier, whereas my 17-year-old daughter is. And I mean, she's really into all that sort of stuff. So when I took her out shopping, and this is my second daughter that I took out shopping for a Honda Civic, they looked at all the different cars and they said, which one can I connect my iPhone to? And then immediately got into it and started playing with the connectivity. So it's very important to make sure that that kind of a technology is on that level of a vehicle, and it's got to match the customer preference. So that's where we're trying to focus as much as possible. And not all technologies are, she doesn't need a 12-way power seat. She just doesn't need that. She needs some connectivity for her iPhone so she can play her Pandora or iHeartRadio and things like that. So it's a very, very different model, and we're trying to change the way that we're approaching it.
From a supplier perspective, pretty much all the products we create in the electronics world are based on a platform. And when we do that, although that target win or that first opportunity may be with a luxury brand or customer, the very next discussion we have is what architecture is this on and how is it spread across the biggest markets in the world from a segment standpoint, the B car and the C car market. When we look at more than 50% of our business in Asia. So we really look at this immediately on how do we develop the architectures, have the platform so that architecture can be flexible enough and cost effective enough where we can meet those luxury market demands, but also bring it down to the affordable levels or have a glide path or a roadmap to do that.
I think, as I mentioned in Toyota's case, the ITS technologies, the goal of those are to improve the safety and sustainability. So I think we take a little more approach that this is a broad, across the board type application. And so I think we're striving for a broader volume to help keep the cost reasonable. Maybe again, not necessarily achieving that today, but that's our objective, just because of how we view the technology. And I think that the important thing, the safety and sustainability, are considering kind of those most vulnerable drivers. So it's the youngest and maybe our more eldest drivers that will gain the most benefit from that safety and those technologies that help support them in those unusual conditions or help assist them as they're driving. So that's sort of our approach.
We've lived in an industry that's for many years been differentiated by horsepower and styling. And it may be the user experience, the ability to access that digital lifestyle is the battleground of the future, at least the battleground for the millennials, the battleground for the Generation X's. Frank, your daughter.
I think all consumers are making decisions on value. And, affordability, can be viewed differently, whether you're affluent or whether you're an entry-level buyer and so on. I mean, I fundamentally agree with John that, it's scale and technology maturity that's going to drive the cost down. And if we can find the way to deliver great value on entry-level vehicles, then, younger entry-level consumer buyers will get into it. But in absence of creating the great value, it's going to take maturity and scale to drive the cost down.
I guess to Jim's point, I'd just like to add, the premise of the question is that, it's sort of a top-down type of approach. And to a certain extent it is in the very embryonic days of a technology. But I can tell you we've got a dozen active safety technologies that we offer across the General Motors North America lineup. Things like side blind zone alert, full speed adaptive cruise control, collision mitigation braking, and. I could go through the whole list of 12. And they aren't just on one vehicle or for one class of buyer. Some are more focused on certain segments than others, but at some point in time, you can really roll these things out if you can get down the cost curve and get a much broader deployment. And so I think it's all about trying to work to find the most sensible way forward to roll these technologies out that can have a profound impact on the safety and the driving experience of our vehicles, Some vehicles are going to come sooner than others, but at the end of the day, hopefully the industry as a whole benefits.
Well said.
Just to add on, insofar the question is really good because Jim, as you are saying, the maturity of technology and scale is driving the penetration on the market. But ITS have function which cannot wait until the maturity and technology is done by 2, 3, 4 generations. Look, for example, V2V. So if we really started only in the high end, a little more every year, then it takes too much time to make the ITS functions happen. And here I think we are all obliged really to make up our mind how we can shorten up the wider introduction phase on higher volume by this kind of systems.
Okay, one last question, and I'm going to finish with a speed round here, but the question before the speed round. A lot of folks asking this question in many different ways. And you talked about V2V and being able to have General Motors vehicles talk to Honda, have standards that would facilitate that, not just in the US, but probably around the world. But that greater network, that ecosystem that has to be created to accept the data, the V to I, the thing that synthesizes all this and spits it back into the input into the cars. What are your thoughts on who should manage that V2V wireless network or that ecosystem?
At Honda, we believe that obviously government plays a big role in it, but it can't be government alone. It would probably be some consortium of industry joining together with government in order to make the rules and enable them and to make sure they're all standardized across and implemented uniformly across all the different industry partners. So we don't think that it's just one company or one government. We think that it's perhaps a consortium of everyone working together is our thought.
Anybody else want to tackle that one?
Actually, just a quick comment. The V2V based on DSRC is based on a technology which is called 802.11a wireless LAN, which started the standardization in late 90s. And now we are in 2014, and we're still talking so you can imagine during this process, there has been 3 generations of technology coming up. So if we make it more ad hoc and keep the standardization just to handshaking for interoperability, that can make the process a lot faster. I was involved in the early stage of 802.11 IEEE standard in year 1999. And it's now 15 years and the SRC still is in debate. So the more ad hoc, the faster deployment. Of course, we cannot compromise interoperability.
Okay. Anybody else?
It's a tough question because there's a big piece of this is the certificate and credential management and so on. And we can all think on the negative side of things on where we don't want that, right? But I agree that it's going to take some kind of consortium collaboration or whatever to allow for the trust, to allow for the speed of development and so on.
Okay. All right, speed round. I'm going to put them on the spot one more time here. And the question is, how soon, what year, will a commercially viable autonomous vehicle be on the road? And by that I mean driverless, self-piloted, fully autonomous, fully automated, however you define it. The driver is extracted out of the driver's seat. Now, John was bold enough to go where none of the rest of you had gone before, which is he put a number out there. But I'd like a year that you think that would occur. Ralph, I'm going to start here.
I didn't put a number.
2025.
Yeah. No, you didn't.
2025.
No number.
Well, I don't want to hear the number.
No, the number's unclear. I would invite people that want to understand a little bit more about some of the challenges that have yet to really be dealt with. Read the MIT Technology Review August 28th issue, and they will, and some of their previous issues, by the way, that talk about the situations that have yet to be dealt with, that when you talk about automated, you can cope with that. When you're talking driverless, I got to tell you, the standard is very high for driverless. Very high.
I agree. It's definitely at the top of the hype curve. It's very romantic to talk about it. I want to hear what you guys think the reality of that is. 2025.
2025.
At the earliest.
2025.
Sometimes
okay.
next decade.
In the next decade. The next 10 years?
Next 10 years.
Okay, so that means by 2024. Okay?
2030.
2030.
I don't think we'll put it, just like John, we can't put a date on it. There's so many things to work on in between, so many opportunities to work on in between. You know, we're going to work our way toward it in solving those problems in the short term. We're going to learn a lot, and as we learn, we'll get a better ability to predict. There's just so many challenges yet for fully autonomous driving.
Okay, so it's beyond 2025 is how I take that.
Post that.
Okay. Kristen?
Certainly, post that. I think driverless is, as we mentioned, a whole different scenario to deal with. And in Toyota's direction and strategy really includes maintaining the driver control. Even if we can offer assistance or some type of automation under certain conditions, we need to maintain the driver in the system. It's too complicated, and that's the safest way to operate for us. So far beyond 25.
Far beyond 25. Frank?
Yeah, there are so many variables that are outside of our control in that type of a situation. And Honda truly believes in personal mobility. We believe in fun, clean, safe, connected cars. And we don't really think that it's just a car driving by itself. So now there may be some aspects of a car where it may park itself or something like that, but that is not fully automated, and that's definitely not driverless out there going anywhere, anytime, any place, I think, which is the presumption of your question. So in that particular case, far beyond 2025 is what we would say.
Fair enough. John, you want to have the last word here?
Well, I would just say that I think the fascination with when we get to driverless is, it's interesting, but I don't think it should take our eye off the prize. The prize is really cars that don't crash. Imagine the societal benefit if we can get to cars that don't crash, even if we have drivers in them, as opposed to this driverless future where we can do additional things beyond that. Imagine the trillions of dollars globally, and it is trillions of dollars globally. In fact, Mary Barra said last night that the traffic accidents are about 1 to 3 percentage points of a country's GDP. Imagine if you can eliminate all of that. Imagine the fatalities, the injuries, all of the costs that are avoided just getting to cars that don't crash, which in my humble estimation is a far easier goal to get to than this driverless future where the cars are basically running around by themselves like drones. You know, that's going to happen at some point in time, make no mistake. But the point is, there's a lot that we, as a collective industry, can do along the way to that future that's going to drive a lot of value to society.
Collision-free society.
Collision-free society, I like it. I'm with you. I don't know if we'll ever extract the driver personally, but there's a whole bunch of socioeconomic benefits you can accrue between here and there, already accruing with many of the systems that you all have on your vehicles now. 1.2 million fatalities a year, every year. That's one every 30 seconds. 90% of accidents come from human error, and we can address that directly with technology that's on the road today. That can have a massive impact, and you never have to extract a driver to achieve that. So I'm with you.
That's a noble goal.
Let's finish up here. Great session. I want to close this out with just a couple of comments here. I appreciate the provocative questions from the audience and very much the candid dialogue from the panel here. And as a reminder, the CTO Summit continues this afternoon at 3 p.m. with a session on connectivity and automation. It's moderated by Dr. Peter Sweatman. And then tomorrow at 1 o'clock, a session on future mobility. It's moderated by Dr. Andrew Brown. And on Wednesday at 1:30 p.m., a session focused on government and policy, moderated by David St. Amant. With that, let's close and show our appreciation for the great job these speakers did this afternoon. Thank you.